Good day to everybody out here. My name is John Olivares, and today I would like to present to you my Eco Exchange presentation on behalf of gas emissions that are going on in our atmosphere. This presentation is being recorded, and with that, let's get started. So let me share my screen. Let's see where the file's at. Okay. Give me 1 second. Okay, so this is my Eco Exchange presentation, How to Improve Gas Emissions and Other Waste Products, by me, John Olivares. As you see in the photo right here, you have tons of gas being emitted from these smokestacks and power plants in various amount of places in the United States. Today, I would like to go into depth on behalf of what is going on with our gas emissions that are being emitted into Earth's atmosphere. Profile is so I have an overview on the charts listed to the right hand side of the screen. The atmospheric carbon dioxide between even it cuts off a little bit, so bear with me. So as of 1960, we're at 320 parts under 320 parts per million on the carbon dioxide concentrations at Mauna Loa, Hawaii. And currently standing in the present day, we are hovering over the 400 parts per million mark in carbon dioxide. So, and with the carbon dioxide being the factor that's playing a role in our atmosphere, we need to pay close attention to this because this can affect various amount of factors that I'll present to you a little bit later. Regarding methane, as of 1978, we see about 1570 parts per billion in 1978, and it gradually increases, rapidly increases between 1978 and 1990. And currently, in the present day, we're over 1,800 parts per billion in methane. So the charts listed on the right gives you an understanding and brief overview of the levels of increase since the mid 1900s to now in the present day. There has been, based off the trend that you see, a rapid increase in levels of greenhouse gases that are emitted into our atmosphere each and every day we stand on Earth. So the big question that we need to ask ourselves in this situation that we're undergoing is, how do we mitigate through these scenarios? Well, the answer to that is our plan to have a healthy environment is to limit the anthropogenic interference, other known as human behaviors, with the emissions of greenhouse gases such as methane, carbon dioxide, nitrous oxide, and etc. In order to sustain our climate, we must limit the burning of the fossil fuels in vast areas around the globe and stop the storage of sinks in our forests and oceans to where they can hold these greenhouse gases before being evaporated into the atmosphere. The ocean plays a big role in evaporating of concentrations that go into the atmosphere, because eventually when you're evaporating something, you're turning a form of liquid into a gas, and that eventually goes into our atmosphere and even in our upper layers. So the ocean is a huge indicator and a good source to produce these gases. So going into what I was talking about earlier about the carbon dioxide methane concentration levels increasing as the day. So we're going to go into the negative impacts of these gas emissions. So as you look on, these are pretty much graphics and charts that I'm showing you here. There's no content in the slide. As of 1995, we on the upper left corner, you see the global mean temperature over the land and the ocean surface. So 1995, we kind of see our global mean temperature at around. We kind of see gradually increase. The global mean temperature was around 20 degrees Celsius. Hold on, let me see. I'm sorry. It's the sea height. So here's the sea height as of 1995 is it was around 5 to 10 millimeters of increase in the sea height, and as of then to this day, everything rapidly goes up, and as of right now, we're undergoing in the present day over 80 millimeters of rise in sea level. So leading into what causes the rise of sea levels? Well, what causes these rise of sea levels is the global mean temperature warming up because the warm air, hot air rises, in which you can form these thunderstorms and complexes out in the ocean. And with that situation, another focal point on why the sea levels are rising is what do you think? The global mean temperature rising, it melts the ice caps. For instance, such as Greenland and Iceland, anywhere around the Arctic, and there's global mean temperature warming the surface of the Earth. Then you're undergoing these ice caps and glaciers melting, which causes fresh water to be dumped into the ocean, which eventually makes our sea levels kind of gradually rise. If global mean temperature were to be a factor on land, and then you'd be having more extreme weather events and precipitation events, such as on the lower right hand corner, you see a mesoscale convective complex over the states, over 4 corners of a state. So these mesoscale convective complexes can occur if the global mean temperature were to rise more and more and more throughout the years, which causes more extremes to occur over land. Now in the ocean, what we see in these global mean temperatures rising is if the temperatures rise, then we get more cyclogenesis into our oceans. Meaning you have more cyclogenesis occurring, that will make a focal point of these hurricanes to not only last longer, but the intensity of these hurricanes will become more of an impact towards human life, because human global temperature, if it rises, will feel warmer, because a hurricane can form over warm water. Excuse me. Warm water is the focal point for a fuel source to make these hurricanes become stronger. With the global mean temperature rising, these hurricanes are not only going to become more frequent, but they're going to become more intense as the years progress. And they're even talking about making a category 6 added to the Saffir-Simpson scale. So we can't rule out these extreme events, especially when there's global mean temperature rising, in which it also plays a role in the rise of sea levels. So what do we learn from today's lecture? What the general public should be aware of today is that the amount of CH4, methane, and CO2, carbon dioxide, and other greenhouse gases such as water vapor, etc., have excessively gone up ever since the 1800s, and should be aware of how to limit and mitigate throughout humanity. So I advise each and every one of you to sustain our climate out here, and to the viewers of this presentation, to please control what you emit in Earth's atmosphere, because what humans emit anthropogenically can travel abroad and cause more and more hot air to rise, which will fuel up these storm systems to occur as the global temperatures keep making an uptrend, to which convection plays a role throughout our upper level systems taking place, meaning that you'll see more storms occur when the level of free convection has more of a gap in between the QT charts. And right here, these are my references to where I referred the sources to my presentation to. So with that being said, let me stop sharing my screen. Okay. Stop share. With that being said, thank you for viewing my presentation. Hope you get a good understanding of what is going on in our Earth's climate system nowadays. And you have a great rest of your day. God bless you all. Thank you.